Alright guys, tomorrow I have to go to Woolaware for girls touch football. So we have to cover 2 exercises. Are we going to go what? Those girls. It's Thursday, guys. Oh yeah. Alright, guys. If I'm in a car on M1, where's the M1 now? It's an old F3, okay? Going from Sydney to Newcastle. Okay. The speed limit on the M1 is 110 kilometers. Alright? So I get on the ramp at Hornsby. I put on my cruise control. What is cruise control? Where the car just goes on a set limit, set speed. So I'll put a cruise control on 110 kilometers per hour, right? So at Hornsby, I drive for an hour and a half. How far am I, after an hour and a half, how far am I from Hornsby? $165 kilometers. 165 kilometers from Hornsby. How did Lucas work that out? So 1 hour, for every hour the car goes 110 kilometers. So this is Hornsby. Right? 1 hour. How the car's moving at 110 kilometers per hour. So after 1 hour, there's 110 kilometers. 1 hour. Okay. After half an hour, another half an hour. Half of 110 is 55. So in total, 165 kilometers. Okay. So after 1.5 hours, I've gone 165 kilometers. Okay. Yeah. So in a linear relationship, what we do is we can graph it. On a graph, you have y-axis and x-axis. What do you put on the y-axis of this? What are you dependent on? In order to find out how far you are from Hornsby, what are you dependent? What do you need to know first before you can calculate the other?
Speed.
The speed. Yeah, you know the speed. The distance. Before that.
Time.
The time. Okay? Because you can only work out how far you are from Hornsby if you have the time. Because you know, what do you know? You know that you set cruise control for 110 kilometers per hour. You know that. Okay, so cruise control. CC, cruise control. You set that. So, what do you need to find out? You need to find out. So, I need to find out how far am I from Hornsby after 3 hours. After 3 hours. So, you find out your time first before you find out your distance. So, time is independent and distance is dependent. So, whenever you graph it out, the vertical axis is what you're trying to find out. In this case, I'm trying to find out how far I am from Hornsby. And the horizontal axis is is the independent, is what you know, okay? The variable you put in to calculate the variable you're trying to find out. So here's my time in hours. Here's my distance in kilometers. Alright, so okay, after 1 hour, what's the value for distance in kilometers? 1, 2, 3, 4, 5, 100, 200, 300, 400, 500. So that's 100, 200, 300, 400, 500. Okay, so after 1 hour, where am I? How far am I from Hornsby? 110. There's my point. After 2 hours, how far am I from Hornsby? 220. So 220 out. So there's the point. After 3 hours, 330. There's 330. There's a 3 there. So, and then after 440. And why is it linear? Because if you draw a straight line up, after 0 hours, where am I? This is 0 from Hornsby. Okay, so if you dot all the points together, it's a straight line. Okay, a linear relationship means the variables on the bottom. You need the variables on the bottom to calculate the vertical variable. Make sense? Okay. Vertical gradient. What does gradient mean? Gradient means the slope of the graph. So, in this case, let's have to run this graph up. Gradient equals rise over run. All right. So I'm going to use 2 points here. This point and this point. No, 3. That point. What's the value of my rise from here to here? What's the value? This is 440, no, this is 330, and this is 110. So the difference, what's the value of that? Can you tell you? There's 330 to 110, so what's the difference? From 110, I move up, how far do I move up to get to 330? 220. Okay. From 1, how far have I gone to get to 3? From 1, how many units have I moved to get to 3? 2. So the gradient is rise over run. So that's 220 divided by 2, which equals to 110. Yeah? What do you think the intercept is? Where it crosses the y-axis. Okay, let's put this up on the board. Oh, by the way, I think our class is the highest class average in the assessment task. So well done, folks. Okay, exercise 4A. Sorry, 5A. Okay, I'll put this on the board. Graphing linear functions. A linear function makes a straight line when graphed on a number plane. So there's my straight line. There are many everyday situations that result in a linear function, such as the distance traveled as a function of time. The graph of d equals 50t is shown. So what do you reckon the graph that I drew up? D is equal to d, distance, is equal to something times time. What is that something? Speed. What's the speed? What's the speed there? 110. So for this particular example on the M1, distance is 100 times time. So when you plot in what's time? 2 hours?
1.
Then what do you get? 220 kilometers. You put in 3 hours, 330. You put half an hour, 55 kilometers away from Hornsby. So, okay? And if you put in, what if you put in 0 hours? 0 times something equals 0. So you're at
0.
the start. You haven't gone anywhere. Independent and dependent variables. So, the linear function d equals 50 has two variables, d the distance and t the time. Time t is the independent variable, so it's on the right hand side is the independent variable, and the left hand side is the dependent. What are you trying to find out? What are you trying to calculate? What are you trying to compute? So d equals 50t, so what you're trying to find out is the distance as a function of time. As any number can be substituted for this variable, such as t equals 1, so you can plot in t equals 1, t equals 2, t equals 3, t equals 4, and so on, to get the value d. Conversely, the distance d is dependent on variable as it depends on the number substituted for the independent variable. Okay. So in order to find d, you need what? You need values of t to put in. So it's dependent. It's a bit like mum and dad. You're dependent on mum and dad for money, for food, for clothing, for shelter right now, because you're not working, you're not earning anything. But once, in the 10 years' time, when you're old enough, when you have skills, mum and dad say, John, it's time for you to make your own way. So you go out and you have to provide for your own shelter, your own food, and so on and so on and so on and so on. Okay? You know when I was at school, right? Everyone couldn't wait to get to 18 and then move out, because back then it was really affordable. But now, if you can move out, but to live in the inner city is really expensive. You're looking at what? Maybe $200 for sharing a room, or so $200, and then probably about $50-$60 for worth of food, and then your outgoing and so on. So you're looking about $300 a week to live frugally. So where's it better? To be toast and baked beans 7 days a week in not a nice place, or mum and dad, we have a good variety of food, it's warm, and so on. What's that? So now, one generation later, folks who are 27, 28 are still at home.
Yeah, nah.
Huh? Alright. I'll catch up with you in 5 years' time.
Yeah.
And you tell me whether you're still at home or not. Graphing a linear function from a table of values, right? Table below shows the cost of postage C as a function of weight. So what do you mean? So in order to find out the cost, you need to know the weight of the parcel. So C as a function of weight. So on your graph, you will have weight and cost. Right, so the first one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so there's 1.2, 2.4, and so on. So there you go. Okay. Have a go at exercise 5A. Have a go at exercise 5A and 5B. So just before you go, intercept. Intercept is where it crosses the y-axis, the vertical axis. Okay? Alright, 5A and 5B.
Wait, so where would the intercept be on that graph?
0. Because where does it cross?
Okay,
Space.
and X is the one that goes horizontal.
Yes. X, Y. You always need X to work out Y. Best way to remember, guys. My daughter's learning the alphabet. A, B, C, D, E, F, G, H, I J, Y. X, Y, Z. Right? So X comes before Y. So you need X to work out Y. Best way to remember that. What do you smoke? Yeah, what brand? Huh? Champion. You roll your own.
Very interesting discussion.
Who's smoking there? It's alright. I was not in trouble. Who's a smoker? I know there's one, at least one. Anyone else? Me, I don't smoke. Come on, Pascal.
He's a bit of a smoker himself.
What's that? 5A. One more day, tomorrow you get them back, okay?
I'm doing the hard one.
Jeez, Aaron has skipped maths.
No, sir. You said we had an appointment.
No.
No, don't try to
Wait,
cover
so
up for a
this-
baby.
Sorry, I swear.
At least get in trouble yourself.
I would be in trouble. I'm here.
Wait, is the independent variable go at the bottom?
Independent, yeah.
Oh, I live in the baby. Yeah, she's good.
Personally, if I was a principal running a senior campus, and then if you skip classes, okay, that's fine. But I know when your results come out, then I know who's been skipping classes and so on.
Down, This is my football. So what is that blue dot? What is that blue?
Go on. Sick.
How straight were you, baby?
Okay, guys, tomorrow it's exercise 5A and 5B. Okay, so it's about linear relationship. X comes before Y. So X horizontal, vertical. Yes.
Oh my God.
What? What about waffles? Okay, if you win tomorrow, I'll give you guys an ice cream from McDonald's.
We didn't have that offer, sir.
Yeah.
So we would have won if we had that offer. Extra incentive.
That's not bad.
It's still cheap.
This is actually joking. So I'm scared to do this fun. And I'm not having fun yet.
Come on, guys.
Down.
I'll find that next night as well.
Never to be seen again. Are you sure about that?
This is a dream. Haunting you back. So, go with that.
Alright.
Yep. Station before Canoa.
So, who are they facing?
Woolware.
Are they good?
Apparently so. But don't worry, there's always a first for everything. Okay. Questions on the board, mister, so you
I'm sorry. Nels is very generously.
do you want to go to the Easter show?
How many seconds?
Hey, can Tamara give you some free tickets to get in? Yeah. Huh?
How many seconds?
Oh, is that a rule? How would they know? So is she working now?
Oh, look. Yeah. True, right?
Come on, Nina. Yeah. What happens is whenever. So you got Y, and then with the 2x. Right. So on this side is what you're trying to find out. What you're trying to find out, right? And then that depends on what. Depends on what you say. If you don't know X, you don't know Y. Okay, so remember this is an alphabet. X, Y, Z. X comes before Y. So you're going to know X before you can know Y. Okay? So now, for example, now we've got on the F3, distance is equal to 110 times, right? So this is on the right hand side is the independent. So we see Team travel 340 kilometers, right? So 340 kilometers is equal to 110 T. So T equals to? Yeah, no, this is independent. No, because they're working reverse. One hand side is always. But, okay, I get what you're saying. But now you've got T. Right, so here. D is equal to 110 T, right? If I do like T is equal to D divided by 110. Right, so I'll replace it. Now on my left hand side I will not be able to find T if I know what is there. Yeah. What do you know about T? T is fine. It's going down to You're right. Whenever you have an equation, the left-hand side is always the...
What do you think that is? Why do you just keep running?
Right. Okay. Have you ever seen a football hitting a student on the hand, playing an iPod, playing an iPhone? Yeah. Oh, it's not going to happen now. In a class?
Oh yeah, that was a shit fight.
Free violence, though. Free violence.
Violence? Yeah.
I'm not looking now.
Come on, guys. Don't just look at them. Go do something else.
I think it's 16.
Which one? Which one?
They don't understand.
What is the dependent variable?
Am I right? Yeah, obviously not right. It's not a number.
The cost. Draw a graph of weight against cost. What is the independent variable?
So here's draw a graph over
Come down. Down. Person on the board.
On Sunday?
No.
Were you crying after 5 balls?
No. I was more sad than painful than something else. Column.
I'm not implying that I do.
Julian, you're going to do some work, my friend. Pascal, we're going to do some work as well.
Better like
Yeah.
Yeah, okay. Why am I looking at the comments?
So, you know, in your table, does it matter if the independent and dependent is either way around?
They usually go independent on top and dependent on bottom. Okay, see here? See here? So the cost is depending on the time. So independent on top and dependent on the bottom.
Yeah.
What you're trying to find out goes on the bottom.
Yeah.
So you have civilized. Oh, look at that. Now, look at it. Look at it. Idiot.
Come on, Julian and Lucas.
So much that's work. Solid. Solid. He dropped Nathan Webster. It's awesome. That was today. What was the song?
Always the best.
Started the night. That was epic.
And the knife is
It was actually then I was like, I'm not impressed with you guys. Not impressed one bit. Just how sick he is. So what was the dependent variable being 3?
What's that?
What was the dependent variable being 3?
Say it again.
The dependent variable in 3.
3.
Yeah.
It is mass time. So the independent
Yeah.
is the mass.
So how do you know it's not?
No, sorry. Time. The conductor science experiment represents the result. Graph of mass against time. Yeah, so mass is vertical, time is horizontal. So independent is time, dependent is mass.
So mascot is on the bottom, sir. Mascot is on the bottom.
Mass is on the bottom. No, time
Time's on the
is
bottom,
on the
sorry.
bottom. And mass is on the
Now, so you try to keep the wrong time. Now,
V is equal to minus 5t plus 30. Yeah. So what is the initial cost of computer? The initial cost of computer is when t equals to 0. And what is the $100 which you measure? Does that mean? So it's $100 now, so value is 100. So 100 minus 30 is 70. So t is 14. Okay. So in the graph, would I do v equals minus 5t plus 30? So what's? But I'm going to take away from 100. Yeah. So there's your axis. Right? V. So this is V. Minus 5t plus 30. So, you know, I know from 30 you've got a cost on the x-axis. Right? And then, so, minus 5t minus minus 5. When t is 0, v is 30. So there's that point. Right? And now, when v equals 0, 0 is v minus 5t plus 30. 5 is equals 30 is equals 6. So you know, my niece is only just trying to do that.
Oh, that's smart. You find out what the
Okay? So you got the equation v minus 5 plus 30, right? So you know, so let's see. So let's equal 0. Let's equal 0 is here. Let's equal 0 is here. So it's 0. Let's say, easily that you find out. Let's equal 0. Is 0.
So the massive.
Then my signature will probably go. Well, if I want to use it, better arrange it.
They kind of look like that looks like an arm. And then you put the face.
Don't make it look like an arm. Don't make it look like Alice. I do that. Because you're just such a big family. Yeah, oh yeah, I suppose he is pretty easy to recognise. Yeah. He didn't know, yeah.
Miss Eastern.
It was such a weird
Mr. M. Eastern. I like the phone. What apps have you got on it?
Oh, jeez.
Guys?
Not anymore, but it was saved to like
Where you got your phone?
I was walking oh no, it's the weekends like.
Is it upload?
Wait, look. These ones are You wrote? Did you like the tech?
Nah. I like the phone. What are you holding? Huh?
My ruler.
Oh, it looks like a pipe.
Wait. Get a little bit of information.
So tomorrow period 1, guys. So continue to do 5B, 5A and 5Z.
No, that's like to tackle. Look how hard it's squeezed. Like, you can't squeeze it.
what is it in your state?
Take one of them. Now, we all know your history. One off.
In the U.S., it's like people give their shit down. I know. Like, it says U.S.
Shit, I've got a heated bag.
Can I follow it?
I didn't read it.
Oh, sorry.
If you see the eyes go back, what are you doing?
Hopefully they are. Answer.
I didn't.